I'll do it. No, you sit down. I'll do it. Thank you.
Use the
That's good.
Forward the email to this one, and then print the email itself. Don't send a screenshot.
Hey, come on in.
Not come yet.
Now that projector, you realise you will knock it. Oh, come on, it's a little rain, it'll be fine.
I still don't get how it can be sunny and rainy at the same time.
It's a special talent we have. Special Irish ability, yes. Okay. Now, we have our homework to do. Or yes, we do. The question I gave you yesterday. That's right. Let's have a look at it. Don't knock the projector. Wait. Don't knock the projector, because I can see what's going to happen. You're sitting here and you're going, "Hey, Fuang, have you got it?" And that's going to be gone. Yes, exactly. So maybe we'll just move this down a little bit.
Don't worry, I won't knock it. I'm very careful.
Or you can just move the projector.
What did I say? My heart.
Okay, guys, come on. We'll do
Okay.
which lesson was it? The principle of moments. Yeah. Yes.
Do you mind if I write the notes down on my laptop?
No problem.
Because
Are you going to pop by tomorrow? Am I going to see you tomorrow? Yeah. At like 11:15, something like this. Yeah. Are you free at 11?
Mr. Clay, no, I'm gonna go.
I think you are.
Yeah, I think we have a break at that time.
Yeah, because I remember someone saying that.
Then yes, we do have a break.
Super. Okay. Let's have a look at the question here. Did you try this one, Lee? Not convincing. Right. Again with the steel. A beam of steel 2 meters long is lying horizontally on the ground and it has 60 kilogram mass. So first thing that happens is the man lifts the beam up from one end. Okay, let me just draw that. Where's my pen? There we go. Right, how long is the beam? It's 2 meters. So where would the centre be? Of course at 1 meter. And what did I say was 50? 60?
50?
50?
60.
40, 60.
So I don't understand sugar language. 60 G. And what happens here is the man lifts it up at, well, that's not really right, because he's lifting it up at this end. So what's happening is he's trying to make it turn which direction? Anti-clockwise, and this one is, guys, don't worry, I won't let anything happen to you, okay?
So it can be clockwise or
This one,
anti-clockwise.
it depends which way round you draw. This one is anti-clockwise and this one's clockwise. So we need his turning force of the man needs to be greater than or equal to the turning force of the weight. Equal is the minimum, but if he actually wants to turn it, really, it should be a little bit more.
wait, if it's equal, what happens?
Nothing.
Well,
So he doesn't even lift it?
it's not the point of moving. So any extra effort would cause it to move. It's kind of at equilibrium. It's literally at the point of just about moving. And even one tiny bit of extra effort would cause it to turn. But I suppose technically it wouldn't actually move. It would just be perfectly in balance. But it would be on the point of movement. So even if a little child came along to help him, it would start to move then. Right, so what's his turning force? Would it be...
60 G
No.
or more.
No, you're doing that thing again where you're not thinking before you're speaking, okay?
Times the distance.
No,
Yes,
shh.
yes.
2F.
I want 5 seconds of silence before you answer, then I can feel like you thought about it before speaking.
Can we know what the distance is?
2 meters.
You already know.
Yeah, I was just asking.
60 G equals to 2 F.
No, listen to what I'm asking you. My question is, what is his turning force?
F times 2.
2F, yes.
2F.
And what is the turning force of the weight?
1.
60G
Oh,
times
60G times 1. So he must apply a force of at least 30G.
Why 2x?
This is the fulcrum, and this is 2.
Force times perpendicular distance.
Is that okay, Kwan? Yes. Yes?
Doesn't the sign change if we multiply? Oh, by negative. Sorry. My bad.
What is this? 30 times 9.81? 294.3. About 294.3. Well, I suppose if we wanted to actually move, we should say it should be anything bigger than that. Would cause it to turn. Yeah. Okay. Next one. Yes, can I continue?
Mm-hmm.
Okay, you're writing this down. Did you not do this last night, Fran?
This is wrong, but I think those are right.
The easy one is wrong, but the hard part is right?
Mm-hmm.
Yeah, makes sense. Okay, can I continue to the B part now? Yep. So the B part, a second man comes to help. He holds the beam 30 centimeters from one end, and the first man, man A, holds it from 40 from the other end. What supporting forces are they providing? Okay, so we still have 2 meters, and there's still the weight in the middle of 60G, but this time there's a man at this end, a distance of 0.4, and then there's a man at this end, a distance of 0.3. No, be brave. I know it's scary, but be brave. Which man is man A? Man B is the 31. So this is the force for man B, so I'll call that FB, and this one I'll call FA. Yes? Oh, please. It's a long week, and there's still Friday to go. Okay, so we have FA plus FB should equal 60G. Yes. Now, where would we place the turning point? At A, yeah. Although we could place it anywhere, we'll place it here.
Can we place it on 60G, like
Yeah.
that line?
Yep.
Yeah.
Would you prefer that? Let's see what happens. I should get the same answer as what you got. So let's place it here. This force, is it a clockwise or an anti-clockwise?
Clockwise.
And this one?
Anti.
Anti. And this one? Ignored,
Yeah.
because it's through the turning point. So this force should equal this force. So what is the distance here?
0.6.
So 0.6 FA should equal this distance?
0.6.
FB.
Yep.
So now we have 0.6 FA minus 0.7 FB should equal 0. Yeah. How can I solve this?
Minus 0.
Two equations, yeah. Yeah, well, what should I do to solve it? Next step.
Subtract
No
or
one.
multiply over 6.
There we go. Multiply 0.6. Why? Well, it will make FAs the same. Then you can cancel them. You do that in maths class with your maths teacher, not me. So I'm not going to bother to solve this because you know how to do that for maths. So we'll be,
Or we can
yeah, we'll be pig lazy and just use the calculator. If you don't want to be pig lazy, you can be dog lazy, whatever your preference. Mode 51. 1, and then 60G. 0.6 minus 0.7, 0. FA is 317 roughly.
Yeah, they got that wrong.
And then FB 272 roughly. Did you get the same answers wrong? Yep. And you took your turning point here. Yeah. Okay, so write that down if you need to, if you found a mistake or whatever.
the digital one is easier than the easy one.
Yeah, you dig that. Yep.
What
Okay.
is it roughly?
Oh, because it's
Well,
it's
yeah.
316.7 or something. Yes, it's okay. Yeah. Okay, continue.
Yeah.
So part C, what's happening here? The two men hang the beam on 2 ropes. Each rope is 20 from the end of the beam. What's the tension in the ropes? So now the two men hang this on 2 ropes. What's here? 60G. And what's the distance from the end, did I say?
0.2, so 0.8.
0.2 and 0.2 here and here, yep. Now there is a trick to doing this one. The trick is, listen carefully, this picture is perfectly symmetric. Do you know this word symmetric? Lee, do you know this word symmetric? Symmetric means the same on the left and the right. A perfect mirror. Balanced, yeah. This picture is symmetric, meaning I can take a shortcut. I know that whatever the tension is here has to be the same here. I can only do that because these are the same. It's symmetric, balanced. So 2t equals 60g, t equals 30g. So t is whatever 30g is.
29453.
But of course, I can tell from your face that this is not how you did it. Right?
Same answer, but
Oh, same answer but longer.
Yeah.
Yes. You said T and you said S? Yes.
no R and
Oh, or and S. Oh, I see. Okay. And you got the same answer for or and S? Yes. Yes, yes, yes.
Why you know that? Why you
I
know?
could tell from your face. Okay. Next part, last part actually, D. Yeah. Man A, I forget who was A,
Right, left.
was left, puts his 5 kilogram tools 10 centimeters from one end of the beam. Man B puts his lunch of 1 kilogram 10 from the other end. What's the tensions now? Oh, I guess it doesn't really matter. So basically you put a 5 and a 1 at 10 and 10. So here what happens now? You still have 60G, but now you have a 10G and also a 1G and
5G.
oh, is it 5?
Yeah.
5, not 10. And here we still have the two tensions. Are they different or are they the same? They're different because it's not symmetric anymore. T and S. This distance, I'll put in red. This one? 0.1. And this one? 0.1. And this one? 0.8.
They're symmetrical.
The distances are symmetrical, yeah, but the weights are not. Alright. T plus S equals what?
Why?
60.
Oh, sorry, yeah, yep.
Why is it 0.01, 0.01, like 0.02?
In the question, I said that his lunch is or whatever it is, 10 centimeters from the end. And remember, the rope is 20 centimeters from the end. Yeah. It continues from part C, yeah.
66G.
Yeah, T plus S equals 66G.
5 plus 1 plus
Did you say 60G? Yeah. Yeah. Where would you like the turning point?
Whatever you know.
That's fine.
S.
You wanted at S?
That should be.
Yeah.
Yeah, okay.
T.
Why are you agreeing with this?
Yeah,
Well, why wouldn't I?
No. You just seemed too positive with his suggestion. Like, yeah, S, good call, man. Right. So, this force, clockwise or anti-clockwise? Clockwise? Anti-clockwise?
Yeah.
Clockwise? Anti-clockwise. Now, it's hard to see, but you have, like I said last time, you have to imagine a hand from here to here. Is that turning with or against the clock? This one is turning against the clock. It's going backwards. This one here is going with the clock. This one here is going against the clock.
But why is it going like anti-clockwise, 60G, the line of 60G?
Here's the center of the clock,
Yeah.
and here's pushing, imagine the hand is here. It's pushing backwards on the hand. It's trying to make it turn this way. Yeah?
So it's relevant to each point.
Relevant to your chosen turning point.
So how do you know that the chosen turning point is clockwise or anti-clockwise?
This one?
Yeah.
No, this one is not turning. You ignore the S because it goes through the turning point. You're calling this the turning point.
But then there's a C over there.
Yeah, that's to the right. So if you imagine a hand here, this one will be making it turn with the clock around. It's a visualization problem. You have to try and visualize what the clock hand is trying to do. So, how many clockwise forces? 2. So let's add them together. Let's do this one first. What's the distance from the turning point? 1.6 T. Plus, and what's this distance? Times 1G. And that should equal the two anti-clockwise forces. The distance? 0.8. 60G plus...
1.7.
Hang on, let me see. That's 1.7, yeah.
Times 5G.
Times 5G. So then you get T would equal 0.8 times 60G plus 1.7 times 5G minus 0.1 times 1G all over
1.6.
when you rearrange it. So let's see what we get for the T. Oh, I can't. One sec. 0.8 times 60 times 9.81 plus 1.7 times 5 times 9.81 minus 0.1 times 1 times 9.81 close divided by 1.6. 346 newtons for the T. So T is roughly 346 newtons. We get the S now. It will be 66G minus 346. 66G minus my previous answer. What did you say?
301.
Yeah, so 302 when you rounded.
I got 301.4 here.
Did you use 346?
Yes.
Yeah, okay. Whatever, close enough.
It was 66G minus T.
Yes. Yes. Question for?
My answer is 349.
Ooh, 349.
Nine.
That's a little bit
The
too.
T.
That's a bit too different. Maybe I did something wrong.
The S is okay.
No, the S can't be okay and the T can't be wrong.
My S is 301.6575.
Yeah, and then the T is 66G minus this.
Yep.
Can you type that in again?
Yes, you have
66.
349, so it's 3. So
But I just typed it in on my calculator. Try it again there.
66
Yeah.
times 9.81
66 times 9.81.
minus 346.
Yeah,
301.
Yeah.
1, 2.
yeah.
Okay, now do the opposite. 66G minus 302. Maybe our T is wrong.
Okay. 66G minus 302.
345.
Don't know for long what you typed in.
345 for T.
Yeah, that's okay. Now, because Fuan spotted a mistake last time.
No, and then I.
Are you using?
Yeah, no, you found the mistake I made last time, so I'm believing you that I made a mistake. So tell me what my mistake is.
Are you using brackets?
Bracket? What bracket?
Oh, Fuan, you know what brackets are.
Yeah, I know bracket. Oh?
Yeah, he wants to know are you using them.
Because that changes the answer.
Yeah.
If you don't use brackets, you get a different answer than using brackets.
It will be like you're minusing 9.81 from whatever you're minusing.
You typed in bracket
I put that,
66G
yeah.
close bracket
Yeah.
minus. Yeah, okay. Yes, Fuan?
It's not a big difference, so maybe because
No.
you're wrong
Really?
before multiplication.
It's big enough to be concerning. Like, if somebody said to me, oh, I got 347, I'm like, yeah, what else? But if somebody said to me, I got 349, I'm like, oh, I don't know now.
Maybe you should just wrote the wrong number. Like 3, 4,
Well, we're gonna find out now.
9. Yeah.
You take back your question?
No, wait.
Question?
Yes. Now I know my mistake.
What was your mistake? We all want to know. Yes?
I found the wrong number.
You subbed in the wrong number. Yes. That would do it. Okay, we'll continue with the next lesson. So, it's going to be more of a turning force. Okay? Right, I'll close this now.